If you took a second to check your answer for question number 5, hopefully you got -4 sine x, because negative refers to the idea that it's rotating backwards, and the 4 is referring to the radius. So hopefully by the time you checked this, you started to make a couple of key connections. First, that the radius number is going to be the number in the front of the equation, and that the sign of the number, and I realize the word sign there sounds misleading. I mean sign as in positive or negative in this context. The sign of the value, or the number in front, determines whether you're heading up or down from your default sort of starting position at 0, 0. So the reason I want to make sure that's clear is because in questions 6 and 7, you're basically going to think about that idea when creating a graph from scratch. Now, the keys to remember are as follows. First, by default, these graphs start at 0, 0. That's a big, important thing to know. Secondly, the positive or negative determines whether the graph heads up or down from 0, 0. So for example, if I was doing graph number 6, this value in the front is positive 0.5, so that implies I'm going up. Now, the last major idea is that the radius of the circle seems to dictate how far up the graph goes before it hits that peak or the top of its hill. So when the radius was 2, for example, the graph went up 2 full units to hit its peak. When the graph had a radius of 1, then it went up 1 full unit. So in question number 6, I'm looking at that number in the front, assuming that that 0.5 must be the radius, and figuring that to get to the top of the hill, because I know I'm going to go up, it's a positive number, the top of the hill must occur at pi over 2, it always does, and that must go up 0.5 units, which must be this little halfway tick mark here. Now, from here, we have to infer the pattern just kind of repeats everything that we've seen before. So I'm going to kind of follow with my finger and my pencil at the same time. I see the graph go up, and then it goes back down. So pi gets you back to ground level again, or back to 0. I'll plot that point. And then after pi, it goes down, and at the bottom of the curve at 3 pi over 2, it hits the very lowest point. And since it's symmetrical, we know that the lowest point must be the same distance away as the highest point, because remember it's a radius. And then as I go back up and get to 2 pi, that must be the end of my cycle. So just so you can see it kind of close up, the idea is that once you get these 5 dots, you'll start to notice they always form a pattern. Starting from 0, 0, we go up the radius, then back to 0, then down however much the radius is, and back to 0 again. So the pattern will continue. Once you're back at your starting position, you can repeat the pattern. Up, and then back to 0, down, and then back to 0. And even if the dots kept going, you can definitely keep the dots going so you get used to it. Up, and then back to 0, down, and then back to 0. Once you connect the dots, the pattern becomes much easier to see because you'll get that wave that we've been used to. And again, if you want to extend it beyond the graph just to get used to it, you certainly can. Now, if you feel tempted to go backwards, it's not a requirement, but at this point you might kind of notice the pattern. You could extend the pattern backwards. If you went backwards, you were going down and then up, and then down and then up. So the next pattern must be down, then back to 0, then up, and back to 0. And you can extend the pattern backwards just so you can see the wave continuing. Notice the wave is completely the same all the way through. Same pattern, same size, same width, same everything. So once you've kind of gotten the idea behind the main ideas, where to start, whether to start heading up or down from your starting point, and whether, or how far up, I should say, make sure that you translate that information to question number 7. I'm going to leave question number 7 as an exercise to you, but I'll give you a little starting point there at 0, 0 that you might want to mark for yourself. Think about from that starting point, where would you go? Think about the equation and the number in front. Which way is that telling you to go, up or down? Then think about the actual value of the number. How far up or down do you need to go? And then finally, the last challenge is, how do you get the dots to form this wave pattern that we keep seeing? So try question number 7, and then check your answer using the online answer key provided in the learning plan. Once you've finished that last question, question number 7, you're done with this lesson. And that was kind of a lot to digest. If you want to work ahead to the next page is going to have more information about graphs on a separate playlist, but I'll leave that up to you. The goal with these videos and playlists is to digest as much information as we would normally get in one class period. So the next page definitely represents what would be a whole separate day if we were doing this in class. I wouldn't necessarily push it too much. So if you feel like you just want to take some time to let the new ideas marinate and make sense for a while, then do that and resume page 23 and the new playlist another time. In any case, if you have any questions about any of the parts that we did, either on page 22 or 21, don't hesitate to send me an email or comment in the Google Classroom, and I'll be happy to help in any way I can.